everyone. Today we are going to see the various water treatment processes which are used to purify the water. As we have seen, the various water sources from which the water can be brought to the water treatment plants by using the intake works, jack well, rising main, and this water we have to treat so that it can be made potable and can be sent to the consumers. Friends, to decide this water treatment, so we have to understand the characteristics of the water source as well. So every water source, it is having its own characteristics. To understand this characteristics, it is very necessary so that the treatment process can be decided. We have seen various raw water sources, and also we'll have to see what kind of type of treatment is to be given to that particular water. The water sources that we have seen as the water sources in general: groundwater, in which deep wells and shallow wells; surface waters, lakes and rivers; ocean water, where we can see regarding the desalinations or the reverse osmosis processes; spring water. Treatment system: single treatment plant cannot treat all the different types of raw water. Remember, it is we have to decide the type of treatment to be given for particular type of water. Every water source, it is having its own characteristics, and we have to understand those various characteristics or the various pollution parameters present in that, and depending upon that we have to decide the type of treatment to be given. Then water treatment plant, or abbreviated as WTP, is very specific to the required quality of water. Okay, in the water treatment plant, various units are there, and every unit has its own function, and we have to be very specific regarding the treatment given in every unit. What are various objectives of treatment? So, if you are giving the treatment to the water, if you are making fit it to make it portable for the consumer point of view, so what objectives are there in front of us? To protect the consumer's health, or make it bacteriological safe. Tap water that you are receiving at home, that should be safe for the drinking from all these parameters. Make it acceptable by the consumers. The consumer, they see the water from the various perspectives, especially aesthetic, in that sight, taste, odor, and color. All these are very important. Economical reasons: for preventing scaling and corrosion in the pipelines. That aspect is also there. Staining the clothes during the laundering. This is also important method. And in some cases, need to make up deficiency in some quality of water. So depending upon the various types of water we can see, so we'll have to see what kind of treatment is to be given, what kind of parameters that we'll have to remember. For example, you can adding the fluoride to the municipal water for protecting the child teeth, okay, or by adding the oxygen by providing the treatment like aeration. So such kind of things that we'll have to think before sending the water to the consumer. Water and wastewater characteristics: what pollution or impurities present in the water. There are three types are categorized as physical, chemical, bacteriological. If you see the physical characteristics of the pollutions in terms of gases, liquids, solids. Solids can be again further classified as the floating impurities, settleable impurities, colloidal, and dissolved. And these are especially easy to remove. Then chemical, in the two parts are there: organic impurities, inorganic impurities, biological, pathogenic, and non-pathogenic. So we'll have to more focus on the pathogenic impurities. Choice of water treatment process. Now, the treatment that we are going to give to the water, that depends upon quality of raw water, as we have discussed earlier. We have to understand what water source is there, and situation of that, characteristics of that. Then we have to also design the see the period of design or years, remember. Then required quality of treated water or end use. So at the remember, the tap water you are receiving, so it is having the characteristics depending upon the treatment given. So at the end users, what quality is expected, that we'll have to also see before giving the treatment. Economic resources available of operation and maintenance. So the best choice for your water, that depends upon the consumer end, and depending upon that, all these units are to be designed. Further, water cannot be consumed in a natural state due to possible presence of floating objects as a, so if the floating objects are there, we cannot. The screening is necessary there. Algae if present, straining or fine screens are provided. Then excessive this ferrous Mn or hardness. So if it is present there, this magnesium and which is in terms of hardness, so we have to go for the precipitation. Suspended solids, in that we have to use the sedimentation. Dissolved gases, we have to go for the aeration. Taste, odor and color related parameters, we have to go for the adsorption or aeration. Then organic and the bacteriological pollution, we have to go for the disinfection. Now if you see this a package of a water treatment plant, so initially we'll have to provide the aeration where water is exposed to the atmosphere. So there are many types of aeration processes are there. So aeration fountains, and that you might have seen, the chemical mixing and coagulation. So these are interlinked. All these units are interlinked. Flocculation and sedimentation unit is here. Then filtration is provided here. So all these units are interlinked. Now the screens are provided to remove the floating impurities or the coarse solids. Screens are provided. What are the objectives of that? Removal of the coarse solids, pieces of woods, plastics, papers, rags, leaves, roots, etc. Protection of pumps, walls, pipelines, impellers. If you are not providing this, that will be burden on all this, right? Now this screen classification is based on opening size, coarse, medium, fine. Configuration, if you see, bar screens are there, mesh screens are there. Cleaning method, if you see, manual, mechanical, racked and water jet. Surface or screen surface, if you see, fixed or moving. So all these are types, remember, of the screen, or you can say the that screening mechanism which is provided. So all these based on all these parameters. Okay, you can see these bar screens are there, or curved bar screens are provided here also, right? So this mechanism is depending upon the how the water you are going to receive. Now aeration process, especially to mix the water and remove the this H2S, CH4, etc. So this is a stepped irrigation. The water is exposed to the atmosphere, and because of this mixing process or the uh, this step process, step irrigation, the oxygen get mixed and the unwanted gases, those are relieved from that. Pre-chlorination. Now we'll have to sometimes provide the chlorination to disinfect the water before starting the process itself. So injecting the Cl2 high dosage of 2 to 5 mg per liter, milligram per liter is decided. Avoided the in waters with good quality. If the quality of the water is good, so not necessarily go for the pre-coagulation. During full length of the period in water treatment plant, uh, CL2 participate, or you can say you have to decide see the life of the water treatment plant as well as so pre-chlorination and all these things, that is very important to from the length of the period of the water treatment plant. Role of pre-chlorination: oxidation of Fe and Mn as a precipitation, then kills algae and bacteria. Long period of contact time is there. Reduces color or odor problems, reduces slime formation. So these factors are also there, which we'll have to see, right? The principles of the suspended solid removal in that sedimentation is there. The direct use of gravity in the form of straightforward sedimentation, where determination factors are particle size and specific weight. Okay, when you're going for the sedimentation, we'll have to see the detention time, for how much amount the water is to be uh, kept as in the detention, right? That depends upon the particle size and the specific weight. Then now depending upon the particle size, the settling time differs. Okay, and particle size that maybe type depends upon the various parameters like gravel, sand, fine sand, clay, bacteria, colloidal particles. So there is a relationship between the particle size and settling time that differs upon the, if the gravel is there over the 1 second is to settle that, and if the colloidal particles are there which are of this size, then you can see understand that it is so only gravity is not sufficient to remove all these particles, so we'll have to give some special treatment to that. Knowing that to remove such particle, the coagulation and flocculation is there, right? What is the coagulation and flocculation? That will just I will see. This raw water is provided to this coagulation unit. Okay, it's like alkalinity is checked, coagulant, that is dosage is decided, stirring is carried out here. Generally, the alum is used. Water is further passed. Coagulant ready is there. Polymers are added. Okay, stirring is carried out, and because of this, again, it is brought to clarifier, right? So this mechanicals is you can understand, and these settled particles are removed from this point. Okay, so the particles which are present in the water, those are called as colloids, and because of the adding the chemicals and this coagulation process is there, then if you are adding the chemicals, that flock generations are there, particles are brought together, and because of the flock formation they will become heavy, and they will settle, they will sent to the settling tank, and sedimentation is there, and those are removed. Okay, so all these things, how it is designed, it is designed to this particular coagulation process is designed, so that part is we are going to study in future. Now, various flocculators, that depends upon the, you can see this horizontal turbine flocculator is there, then pedals are provided here, baffle flocculators are there. Depending upon the design, the flocculators, or can say the configuration changes. Dissolved air flotation, or it is called the DAF. So this type of flotation where the air is the important factor there. The principle is the super saturation of air in the water. Okay, 2 to 4 atmospheric pressure. Bubble size is 20 to 200 micrometer. Now, what are the various parameters? Expose water to the air pressure, saturation of air in water and proportional to the applied pressure. The saturation concentration encouraging solution of air. Amount of dissolved air will increase. Pressure is released to atmosphere pressure. Excess air will escape in the form of bubbles. Basic components of the this dissolved air flotation is a pressurizing pump, air injection facilities, retention tank, pressure vessel, air liquid contact, pressure reducing valve, and flotation tank. So you can see here the flotation tank is there, and if you are providing the pressure and such air relieving arrangement is made there, right? So that so this process can take place, and this air flotation can be efficiently work. So here you can see these small air bubbles are there, which are formed because of the compressed air provided from the bottom of this water. Sedimentation. Now you can see these sedimentation tanks you can observe. Okay, the water is stored here and it is detained for this, some time, and water after sedimentation that can be removed. The supernatant water which is here, that is sent to the next unit, and the settled particles, those are removed. Okay, so these are the sedimentation limits are there. Okay, you can see this combination of the sedimentation and the clary flocculator is there. Sedimentation is there, and this clary flocculator, the stirrer is provided here. Okay, if you are adding the chemicals in that, and because of that, the flocks are going to form. Then in the sedimentation also the various configurations are there. This is a this we are going to study afterwards, but only today I will introduce that. It is called as a various settling tubes are there, settling types are there, settlers are there. This is one of the sedimentation type, which is a lambda settler, where these inclined plates are provided here, and because of that the particles are settled, because due to some angle provided, settled down earlier. Okay, some these pulsar tubes are there, tube-like structures are there. You can see here these are provided in the water, and because of this particular pulsar tubes, the particles settle earlier. Now, filtration mechanism is there. The water is to be filtered, okay, properly to remove the still the impurities which are present in that. Now there are two types are there. One is slow sand filter and the rapid sand filter. Now in the slow sand filter, you can see here the perforated this laterals are there, wash drop is there. This filtering mechanism filter sand, then graded gravel. The depth depends upon the what kind of water you are receiving to that particular unit. Now, what are the basic elements? Generally, concrete basing, minimum two basins are there, so that one can be taken out of use. So, for cleaning and the maintenance, so one standby unit is always there. Under drains consists of pipe and channels to collect and cover the filtered water outlets. Gravel bed to prevent the sand entering in the drainage pipe. Flow control devices at the inlet and outlet having the quasi constant flow out of the filter. Okay, so all these arrangement is provided, so the water can be filtered safely. As I told, the one standby unit can be provided, so that we one unit is in maintenance, another can be utilized. Now this slow sand filter, what are the various features associated? A bed of sand through which water passes together with the necessary structures and control to apply water to flow and to remove the water after filtration. So what process involved? At early stage only a little purification is there. Efficiency of the slow sand filter depends upon the establishment of a biologically active surface material of a gelatinous biomass on the filter surface. This layer assists in retention of suspended solids and bacteria. Okay, because of the continuous use of that, so this layer is going to form, and which is very effective into removing this solids. Once this layer becomes too dense, that will create too much of a resistance to passage of water, leading to an increase in the head loss beyond the acceptable limit. So we have to keep watch on this. This head loss should be in the acceptable limit, and depending upon the, we have to keep on the functioning of the this layer. The filter bed is cleaned manually. That depends frequency 1 to 3 months, and the top 50 to 80 of sand is removed. Then the removed sand is washed and reused. Okay, rewashing is carried out. This is a cross section of a slow sand filter where the raw water inlet is there. Uh, here, okay, this is the layer which is forming here, smudgemic. Then filter blade. Then this is the gravel bed, and the water we are receiving here. So all this, it is not easy that much. That will have to design considerations are there depending upon the um, quality of water and the head loss that resulting. Then second is a rapid sand filter where the you can see the various arrangement. This wash tub is there, filter media, support gravel, under drain. Then, as the name indicates, the rapid filtration is done, and so you can see here the water which is washed, it is sent to the drain or sewer. Clear water is brought to the water tank and sent to the next. This is the filter media you can observe. Then you can see the wash water tank is here for cleaning of this thing. The filter backwashing, remember the sand or the filter media which is filtering all this water, after some time it get clogged with this all these particles, and that is backwashing is necessary, and some arrangement is provided. So what are the units? The closed inlet allow water to filter, air scouring is provided, sometimes combination air plus water, air blower is provided with single pump, backwashing with only water, and two number of backwash pumps are provided here. Always one standby pump is provided there. The basis of selection of disinfection or disinfection is the again very important process which is supposed to be very important as the directly related to the health. So there should be effective kill of the bacteria or the in these harmful agents which are present there. Work under normal environmental conditions, that should work in normal conditions. End products residual should not be toxic. Overdosing or the use of the mechanism or the chemicals, if you are using anything, that should not harm the health of the receivers. Should not be high, more cost. Okay, so it should be low, that should be optimum. Proper residuals should be provided. Then easy, safe to store, transport and dispose. This is also important part of the any disinfection. Then easy in analyzing the dose and residual. Okay, should not be complicated, because when you are deciding the dose of a disinfection, so that should be easy. Treated water should be non-corrosive. So tap water that consumers are receiving, that should not be corrosive. Now how the disinfecting is infectant is decided. Now proper types of disinfectant selection should be based upon the types of raw water, requirements of treated water quality. Two major parameters are there on which the selection of this disinfectant is made. Now there are many types of disinfection methods are there. Now chlorination or the boiling of water, treatment with the excess lime, additional 14 to 43 ppm. Okay, that will increase pH. Treatment with ozone, treatment with iodine and bromine, treatment with potassium permanganate, treatment with ultraviolet rays, treatment with silver called elytra catadine process. So all these disinfection methods are there that we are going to learn. So if you will see that gas chlorination is there. So gas is supplied, right? So gaseous this chlorination is there. So this is a unit you can see. Now effectiveness of this chlorine in the pathogen that depends upon the type of virus. Remember. So this also we are going to study afterwards. So this chlorine per or ppm and contact time, that is very important. Now when you are deciding the disinfection process, you have to understand the chemistry of every disinfectant. So if you so the ozone treatment is there, this is one of the most powerful oxidant, or you can say, and it is a good disinfectant. Best suited with the conjunction with the secondary disinfectant such as a chlorine or chloramine. So ozone is supposed to be ozonation. It is supposed to be very effective disinfection process. Uh, what process you can say, the high voltage electrodes are there. Then dielectric process is there. Discharge space. Then this is the you can see ozone plus oxygen. Okay. Then actually when ozonation is there, so this process should be designed because the there should not be any after effects of that, right? So this is a general schematic process is there of any ozone production process. The ozonation system you can see, the this is the view inside of a diffusion chamber. These are the diffusers are there, and the ozone gas enters in the chamber through the diffusers. And this is the close-up of a diffuser in operation. You can see a single diffuser. This is enlarged, and you can see the bubbles. Now ultraviolet radiation, in that electromagnetic radiation in the shorter wavelength of range, use a spectrum up to 265 nm, then cause die-off of microorganism and leaves no residual radiation in water. The sensitivity of the organisms varies depending on their resistance to penetration of ultraviolet energy. Other disinfectants are there. Sunlight is also considered to be one of the effective disinfectant. Similarly, silver is also found to be used in the for disinfection. Potassium permanganate used in the rural area, right? Now again further discussing regarding this mechanism, destruction and the impairment of the cellular structure of the organization. So any disinfection mechanism is there. So we'll have to how we'll have to understand the cellular structure of the this particular, how we can destruct this. They interferes with this energy yielding metabolism and interference with the biosynthesis and growth of this particular bacteria and these things, that we will have to understand what type of bacteria are present in the water. Combination of this mechanism can be responsible for disinfection depending on the type of microorganism. Now factors governing to the disinfectiveness are this turbidity, organics, pH, temperature, along with that what organic chemicals we are using, right? In the chemicals, this iron, manganese, hydrogen sulfides, cyanides, nitrates. So we have to think regarding this all water characteristics. Now if you are using the chlorination as the disinfection, there are also uh, byproducts formation and ill effects of that. For example, this CS Cl3 supposed to be then CHCl to Br, CHCl Br2, CH Br3. So all these byproducts are very harmful, and these are to be prone cancer causing, especially in bladder. So these are the various treatment processes which you have seen, but in detail every treatment process we are going to study, and every treatment process is having its own peculiarity depending upon the water which is received at the water treatment plant that going to study afterwards. So thank you very much for joining today's session.